Okay, as weird as this is, welcome to our virtual classroom grade 8. I really wish we were back in school because, to be quite honest with you, I miss the routine of being a teacher, being your teacher, and I miss all your personalities and your faces, and we'll get through this, and hopefully we'll be back in school in no time, and we'll be back to a normal routine. But just let me start by saying I miss all of you, and can't wait to see you guys again. So with that said, what we have today is as good as I can give you for practice questions. I have a reach back here with 7 different questions. Now, if you are at home and you have access to a computer, what you can do is you can type this web address into your internet browser. And what it'll do is if you type it in and you go to the website, now mine's going to give you a little bit of a, hopefully I can get it here. Now it's not going to be perfect here, but if you go to it, it's going to take you to this PDF page that has all of the pages of this presentation printed out for you. And if you want to print it out, you can, but you don't have to. You just have to look at the questions, and then what you're going to do is do the work on a piece of paper. And when you do that piece of work on a piece of paper, that's not where I want to go. I want to go to, where am I at here? Right here. Then what you want to do is then just work the questions out. And what I'm going to do here is I'm going to show you the explanation for each of them, so that if you made any mistakes or you couldn't remember how to do something, the explanation will be there for you, and you can copy it out. So the goal is to practice. The goal is to retain the information that you've learned this year, so that next year when you start grade 9, all of that stuff you've learned won't be too difficult to access in your brain, because there'll be lots of neural pathways connecting all the ideas. So the first question, what we're going to do, I'm going to read it to you, and then you can press pause, and you can try the question, and then you can see my solution. So the first question says, solve using both equivalent ratios, unit rate, and cross multiplication. So what I'm looking for is, can you solve it using 3 methods? This idea, and this idea. Show all 3 methods. Don't just choose one. See if you can do all 3. So it says there's $1.20 for 4 bananas. How much for 5? Okay, so go ahead and try that. See how much you can remember how to do, and then when you're ready, just press unpause, and I'll show you all 3 solutions. Okay, so your first way says equivalent ratio. So if I set this up as a ratio, now normally we can do it 2 ways. We can do it $1.20 to 4 bananas. But we said that if we're going to find out missing values, the easiest way to do it is just set it up as what we would normally consider to be a fraction form. Even though it's a ratio form, it's a fraction form in this case. So it's a ratio comparing the cost to bananas. And if we say is equivalent to how much for 5, I want to know in the first way for equivalent ratios, what did I multiply 4 by to get 5? So if I think of an easier question, I said like 1 over 2 equals 1 over 10. What did I multiply 2 by to get 10? The answer is I multiplied it by 5. So if I think about, well, how did I get multiplied by 5? Well, if I take this number and divide it by this number, I will get what my multiplier is. So if I take 5 and I divide it by 4, I should get what my multiplier is. So if I pull up my calculator here, and I say 5 divided by 4 is 1.25. So therefore, I multiplied it by 1.25, and if I multiply this by 1.25, and take my calculator again, pull it up here, and I go, hang on a second, what is $1.20 multiplied by 1.25? When I solve that, I get 1.5, or if we're talking about money, I have to put that insignificant 0 there, and therefore, using equivalent ratios, I figured out that therefore it would be $1.50 for 5 bananas. Okay, so that's using the first method. Now if we use the second method, which is unit rate, again, if I set it up as $1.20 for 4 bananas, a unit rate, remember, is how much it is for 1 banana. So if I figure out how much it is for 1 banana, this is a much easier multiplication, division, equivalency, because I know I have to divide 4 by 4 to get 1. So $1.20 divided by 4, I don't even need a calculator for that. I can do that in my head. It's 30 cents. So therefore, I've calculated a unit rate of 30 cents for 1 banana. And therefore, if I want to figure out how much it is for 5 bananas, I simply have to multiply both by 5, and I get $1.50 for 5 bananas. the same answer as we got with the equivalent ratios. Okay? Now, the last method you were asked to do, I better get this one bigger. The last one was using cross multiplication. And you know this is my favorite one. So it's $1.20 for 4 bananas. How much is it for 5? All right? So if we set it up with the how much is it, meaning the x, and I multiply across the equal sign this way, I create 4x is equal to the product of $1.20 times 5, which I know is $6. So what I've done is I've created this algebraic equation that says 4x is equal to 6. If I divide both sides by 4 like I would with algebra, I get x equals 6 divided by 4, and 6 divided by 4 is 1.5, or $1.50. Okay, so $1.50 would be the cost for 5. So that's just solving using proportional reasoning to be able to solve using either equivalent ratios, unit rate, or cross multiplication. You have to be familiar with all of them. Probably in any given situation, there's one method that's better. But you know, in the real world, if you ever had to use it, you would probably default to one of your favorite methods. Your second question is from Chapter 3 on Pythagorean Relationship. It says solve using a diagram and a formula. So you're going to do it 2 ways. Okay, so press pause, give it a go, and then see if you did it correct. All right, so I'm going to solve this first using a diagram method. So if I wanted to solve this with a diagram, what I'm going to do here is I'm going to draw squares onto all the sides of the right triangle. Because remember, what Pythagoras said, without stating the formula, he said the area of the square is attached to the legs of a right triangle, and those are the legs. The area of those two squares added together, or the sum of those areas, will always equal the square attached to the hypotenuse of a right triangle. So because that's true, if I take this and say if the side length is 8 meters of this square right here, then the area of the square would be 8 times 8, which is 64 meters squared. If this is a square and the side length of this square is 16, then 16 times 16 will be its side length, which is 256 meters squared. And therefore, since Pythagoras said, and I'll use a highlighter for this, the area of this square plus the area of this square equals the area of this square, then 64 plus what is 256? I'm actually going to use subtraction. I'm going to take the area of that larger square and subtract this one. I'm going to use a calculator. 256 take away 64 is equal to 192. Of course, you could have solved it with 2 and borrow here to get 15. You would have got 9. You got 192. Either way, you end up with 192. So therefore, this area is 192 meters squared, because 64 plus 192 equals the area of the square attached to the hypotenuse. But we're not done yet. Because if that square has an area of 192 meters squared, then we know its side length, which is what we're looking for, is the square root of 192. So the answer is x will equal the square root of 192. And since we know 192 is not a perfect square, it's approximately equal to, if I use my calculator, and square root, where is square root on this one? Right there. Then it's approximately around a 1 decimal place, 13.9, as in approximately 13.9 meters long. Okay, so your answer is x equals 13.9. And we'll just put it up there in the corner, x equals approximately, and we have an equal sign with a dot above, 13.9. Okay, so that's the first one, using a diagram. But the second one says use a formula. So if I write out the Pythagorean formula, a squared plus b squared equals c squared, and we know that a and b are our legs, or a and b, then I'm going to put 8 squared plus x squared equals 16 squared. Well, of course, 8 squared is 64. I can't square x because I don't know it, and 16 squared is 256. And once we get down to this, then we have like a semi-easy algebra question where we have x squared plus a constant of 64. So I'm going to subtract 64 from both sides, as I would algebraically, and I get x squared equals 192. And here's where it gets complex. If I have x squared is equal to 192, and remember the algebra idea is whatever I do to one side, I do to the other. So if I square root this side and square root this side, it should maintain equality. So I'm going to square root both sides. The square root of x squared, or what number times itself, is x squared. The answer is x. And the square root of 192, as we said before, is approximately 13.9. So therefore, using the formula, we also get the answer. X is approximately 13.9. Now, for your next question, what you have is a surface area question from Chapter 5. And it says, draw a net of this particular shape and solve. So because it's a rectangular prism, what we're going to do is we're going to draw our typical rectangular prism net, which we were used to doing. And this has all of my faces on it, 6 faces on a rectangular prism. And I'm going to kind of label them. I'll use blue here. I'm going to call this one the bottom. And of course, this one would be the top. This one would be the front. This one would be the back. This one would be the right. And this one would be the left. Okay? Just to get my orientation for my net a little bit. So if I think about the bottom, this part right here that I shaded in would be the bottom. And if I think about what are the dimensions of that bottom, it would be 10 by 5. All right? So if I think about that bottom as being 10 by 5, then since it's a rectangle, the area would be 10 multiplied by 5. So the area of that bottom face would be 50 centimeters squared. And we know from practice that the top face, if the bottom face is 50, then this top face right here also has the same area of 50. So we're going to put 50 centimeters squared in for that one as well. So now we know, centimeters squared, we know 2 of our 6 faces. If I think about the front face, and I'm going to shade it in with red here, this front face has a length of 10 and a width of 4. So it's 10 by 4, which would make that front face have an area of 10 times 4, or 40 centimeters squared. And if the front has 40 centimeters squared, the back also is 40 centimeters squared, because we know that from practice, that those 2 faces match each other in terms of area. And finally, the last one, if this is the right-hand side, it is going to be 5 centimeters by 4 centimeters in dimension, or a total area of 20 centimeters squared. And this will also be 20 centimeters squared. So now that we have our faces drawn in our net and each area of each face put in there, all I have to do is add them together. If I take my, let's do my blue. 50 plus 50 is 100. 40 plus 40 is 80, so 180. 180 plus 20 is 200, plus 20 more. The surface area, therefore, is 220 centimeters squared. So I guess as you're going through these questions, if you made any mistakes, just use a highlighter or a Post-it note. Just write down the mistakes you made in each particular question and then keep that piece of paper somewhere. So as you do a review again, if you're given a question like that, you'll be able to remind yourself either by looking at your past questions, what mistakes you made in the past, and hopefully you won't make those mistakes again. Question 4, if you want to press pause, solve, and show your work, it's an integer question. Okay, so if you are solving this question, you have to keep in mind that when you have more than one operation, here I have addition, in here between the 3 and the bracket I have a multiplication, I have a subtraction, and I have a division. I actually have 4 operations to solve. So what I'm going to do is I'm going to solve using BEDMAS. And of course, BEDMAS is B-E-D-M-A-S. There are only 4 steps. There's brackets, which we have right here. But those brackets aren't really necessary. I don't know why I even drew them. Oh yeah, I did, because of -12. And then there's exponents, which we don't have. Then division and multiplication are 1 step in the order they appear from left to right, and then addition, subtraction. So technically there are 4 steps that you need to follow. So the first one I'm going to do is my division, multiplication, or my brackets if you want. Let's do brackets first, because it is actually there. So I have to actually solve the brackets, and inside the brackets there's -12 divided by 4. Well, 12 divided by 4 is 3, and a negative divided by a positive, as we learned in grade 8 sign rules, opposite signs is a negative value. So we're going to have a -3 here. So now I have my brackets done. There are no exponents, so now I'm down to division, multiplication. Right here, I have a multiplication, so I'm going to solve that next. -10 plus 3 multiplied by -2 is -6. Now notice how I'm keeping it in brackets because I want to make sure this addition sign and the negative sign are separated. Oh, -6. Take away -3, so now I have all my division, multiplication done. And simply addition, subtraction left. So -10 plus -6 is -16. And -16, take away -3. If you had 16 negatives and you took away 3 of them, you would have -13. Or you can change it to addition of the opposite, and you'd still end up with -13 as your answer. Question number 5. it says graph the first three ordered pairs from the table of values, then find the equation and find the missing y value. Suppose this y value should be down here a little bit. I'll bring it down. Y value. There we go. So the first thing I'm going to do, if you want to press pause, give it a go, see if you can solve it, and then press unpause to figure it out. So the first part of this activity says graph the first three ordered pairs. So here's the first ordered pair, the second ordered pair, and the third ordered pair. And if I wanted to write it out as ordered pair, x is 2, y is 10, x is 4, y is 16, x is 6, y is 22. Those are the first three ordered pairs in my table of values. So if I think about it, here I only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different lines in my y chart, but I have to go as high as 22. So if I think about that, I'm not going to use 1 to 22 because it won't work. But what I am going to do is if I'm going to graph it, I only need 2, 4, and 6 here. So I'm going to actually take my x values, because I only need to go as far as 2 to 6 in my x value chart. So I'm going to keep it 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That works for here. But on my y, since I have to go from 10 to 22, remember what we did here. If I put this little symbol here, that means I omitted, and in this case I'm going to omit 0 to 9. They're going to be squished down. And the first number I'm going to have here is 10. And since all of them are even, I think I have enough space to go 10, 12, 14, 16, 18, 20, 22 I do, 24, 26, and 28. So I have enough space to go all like that. So I omitted 0 through 9, started at 10, and then each of these spaces here is 2 in length. Okay? So that's the first step you had to do, was just decide on what your axes will be numbered. If I take my red one, and the first ordered pair is 210, then 210 will be right there on my graph. The next one is 4 and 16, which will be right there on my graph. And then 6 and 22, which will be right there. And if I connected those dots, right, I would find that I have a line that goes on between those three, and I can extend it beyond the points I know. And in grade 9, you're going to learn that word is to extrapolate points beyond what you already know. So the first part says graph the three ordered pairs. That is done. I have now graphed the three ordered pairs. And then it says find the equation. Now for this one there was a procedure that we used, and we said that in your equation that shows the relationship between, I'll write down x and y, there can be a coefficient for x and there can be a constant for x that relates to its y value. In order to find the coefficient, the difference of y divided by the difference of x will equal the coefficient. So if I think about the difference in the y column, it's going to be adding 6 each time. And the difference in the x column is adding 2 each time. So 6 divided by 2, or the difference in y divided by the difference in x, is 3, because 6 divided by 2 is 3. And in the equation that shows the relationship between x and y, 3 is going to be my coefficient. All right? So now we know our coefficient. But is there a constant necessary? Let me just change this to this. Okay, here we go. Erase all this stuff now. So the next part is to find what is your constant. So if I take any ordered pair, and I'm going to choose this one right here, 2 and 10. X is 2, y is 10. I'm going to substitute x is 2 and y is 10. And since 6, when I multiply 3 by 2, does not equal 10, I know that a constant of plus 4 is required to balance the two sides. And therefore, the equation that matches this table, any ordered pair in that table, is 3 multiplied by the x value plus an additional 4 will equal your y. And remember what we said, if you take this and say, okay, well, let's take this one here, 6 and 22. If I substitute 6 here, I get 3 times 6, which is 18, and 18 plus 4 is 22, and 22 is your y, so it ends up working out. So therefore, the equation that matches it is 3x plus 4 equals y. That's the equation that matches all of the points on this line and beyond the line as well. So if x was 100, which is way down there, but if x was 100, which is what this is saying, what is the y value? So if I substitute 100 into where my x is, and I simplify it, I find that 304 would be my y value. So in here, I can say when x is 100, then the missing y value will be 304. In your next question from chapter 10, it says use opposite operations to solve for x. So if you want to try this, go ahead and press pause, and I'll show you the solution. Okay, this is a fairly easy question. It's not too hard. In fact, if I was to think back to, let's just take my pen here for a second and take this to white. If I was to erase, oh, hang on, take this to white, erase this here. If I was to look at this question right here, this would be a question you would have seen in grade 7. But in grade 8, all we do is we make coefficients negative and values negative and use a little bit of distributive property. So it's not that much different. The opposite operation procedure is the same. I'm going to add 3 to both sides to get rid of my constant. I get negative 10x is equal to 40. Divide both sides by the coefficient, and since the coefficient is negative 10, divide both sides by negative 10, and x will equal negative 4. And your final question comes from chapter 6 on fraction operations. It says, solve, show all of your work. So if you want to give this a go, press pause when you're done. Or press pause and then press unpause when you want to see the solution. All right, here we go. So because there are 2 operations, here we have an addition and a multiplication. And of course, Donovan would tell you that in cases where there are more than one operation, you should always follow BEDMAS, which means we're going to do multiplication first. So 1/15 we'll have to wait. To it, we're going to multiply 1 2/3 as a mixed fraction, as an improper fraction. That is 5/3 multiplied by 4/5. Okay. Now, if you wanted to, you could simply multiply the numerators to get 20 and multiply the denominators to get 15. And then say, hang on a second, that's not lowest terms. Divide both by 5, and you'll get an answer of 4/3. And you can put 4/3 down here. Alternately, what we learned is that when you are multiplying fractions, one thing that we've learned to do is you can cross reduce. So 5 over 5 would reduce down to 1 over 1. And when you multiply it now, you get 4/3. This is what we got before. So if you cross reduced, you ended up with 4/3. If you didn't cross reduce, you got 20/15, which reduces down to 4/3. Now, ironically, you didn't want it in lowest terms, because if we think about it, I'll just delete this here. If I didn't reduce it to lowest terms, I end up with 20/15, right? And I'm going to go over here, and I'm going to keep this 20/15. And the reason why is, if you look at it now, 1/15 plus 20/15 is really easy because the common denominator is already made, and it's 21/15, which is the improper fraction. And as a mixed fraction, it would be 1 and 6/15, which in lowest terms is 1, because both are divisible by 3, and 2/5. Okay, so your final answer is 1 2/5. Okay, that's your final answer. But if you didn't, if you reduced it down to lowest terms, thinking you're doing something brilliant, and you ended up taking that and reducing it down to 4/3, watch what happened. So 4/3 goes here, and you're like, okay, I need a common denominator. The common denominator will be 15. You multiply by 5, and look at that. You end up with the same thing you had before. Okay? 1 and both divided by 3. 2/5 is your final answer. Both divisible by 3. Okay, grade 8. That is a quick review. It's a long video. It's 23 minutes long. Hopefully you didn't overexert your body. But again, I just want to stress how much I miss teaching you guys. I miss seeing you guys in class, and hopefully without too much delay, we'll be back in the old rigmarole before too long. Stay healthy, wash your hands, and listen to your boomer parents.